Welcome to yet another lesson. And in this lesson, we're going to talk about multi-threaded programming in Java. Multi-threaded programming in Java is what we're going to talk about. Now, there are a lot of there's so many concepts that I want you to really capture, even before we go into um, we go into writing code. There are a lot of things that I want you to understand even before we put down any code. Before we put down any code. So we are talking about um, multi-threaded programming. So I'm going to use this area here for my notes. Yeah, so I'm going to have comments and then I'll use it for my notes. So we're talking about uh, multi-threaded programming. This is what we are talking about in this lesson. So unlike some computer programming languages, Java provides us with built-in support for multi-threaded programming. Now, what is a multi-threaded program? A multi-threaded program is a program that contains two or more parts that can run concurrently, and each of these part or each of that type of a program is called a thread. Yeah. So a multi-threaded program is a program that has two or more parts that can run concurrently, and we call each of those parts a thread. Okay, so each thread basically defines a separate path of execution, and when we look at multi-threading in Java, we are looking at it as some form of multitasking. Okay, we look at it as some form of multitasking. All right. Uh, so Uh, there are two distinct types of multitasking that are supported by uh, that are supported by uh, modern operating systems, and the first one is a process-based multitasking. The other one is thread-based multitasking. So it is very important for us to get the difference between process-based and thread-based. So when you talk about the process-based multitasking, we are talking about uh, having two programs running concurrently, or two or more programs running concurrently. In other words, a process is a program in execution. So the process-based multitasking is a feature that allows your computer to run two or more programs concurrently. Okay, for example, you can be running the Java compiler. At the same time you're running the Java compiler, you're using maybe a text editor, or you're visiting a website. So you have two or more programs that are able to run at the same time, and that is process-based multitasking. So when we're talking about the process-based multitasking, we are considering a program as the smallest unit of code that can be dispatched by the scheduler. So you might be asking yourselves again, what is a scheduler? A scheduler is basically a program that schedules processes in the operating system or in a machine. So how does the system know which process to run first, which process to run next? That is made possible by the use of a scheduler. So the scheduler uses different algorithms to schedule processes. There are algorithms such as first in, first out algorithm. We have an algorithm such as shortest job first, that is actually controlling uh, which job should run first, etc, 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 etc. Yeah, so it is really important for us to have an idea of all these. It's really important for us to have an idea of all these. So that is the process based. And then we have the thread based You have the thread-based multitasking. And in a thread-based multitasking environment, we have the thread being the smallest unit of dispatchable code. So the thread is the smallest unit of dispatchable code. Okay, and here we are saying the thread is the smallest unit of dispatchable code. Remember, we said a thread is a part of a program that can run concurrently with other parts of a program. Okay, so it's very important for us to understand the two different types of multitasking. It's very important for us to understand. Now, for you to be able to uh, uh, um, multitasking, when we look at the thread-based multitasking, it basically means that we can have a single program that is able to perform two or more tasks simultaneously. For example, you have a text editor, you are formatting text at the same time. That text editor is printing something. Okay, so as long as the two actions that are being performed at that time are being performed by separate threads, then that is thread based. Okay, so when we talk about the thread based, the process based is actually dealing with the big picture. Okay, but the thread based is handling the multitasking details. That's very important for us to understand. So we have processes. um, we have to understand that processes are heavyweight. No? Processes are heavyweight task, and they need to have their own separate address spaces. We have inter-process communication that is really expensive to achieve. It is also limited. Now, switching from one process to another is also costly. Okay, but if you look at the threads on the other hand, they are lighter weight. Okay, they have the same address space, they share the same heavyweight process. So now in inter-thread communication is less expensive as compared to uh, to process inter-process communication. These are important basics that we need to we need to really have. Okay, now um multitasking enables us as programmers to make maximum use of the processing power that is available in the system. And multithreading is actually uh, able to achieve this by reducing reducing the CPU idle time. By reducing the CPU idle time, in other words, minimizing or making sure that the time in which the CPU is idle is less, so that we are taking advantage of the processing power. Okay, it's very important for us to understand. So um, it is important, especially when we are talking about interactive networked environments where Java operates, because the idle time is common in such environments. For instance, we can talk of maybe you are transmitting data over a network. The transmission rate of data over network is much slower than maybe the rate at which the computer is processing that data. Even when we have maybe some local file systems resources that are being read and are being written at a much slower pace than they can be processed by the CPU. And of course, user input is much slower than the computer itself. Now, for us to be able to understand this, we need to understand the single threaded environment. The single threaded environment. What happens in the single threaded environment? Now, basically, in the single threaded environment, it is of essence for us to understand that there is more idle time here. There is more idle time. because your program has to wait for each of the tasks to finish before it can proceed to the next task. Now, even though most of the time the program is idle, maybe waiting for input, so when we have multi-threading, it is helping us to reduce the time the CPU is going to be idle. Okay, maybe because another thread is able to run when one is waiting. Okay, so another thread is able to run when we have another one that is waiting. So if you you have programmed maybe for operating systems, for example, Windows operating systems, then it means now you are familiar with multi-threading programming. But the fact is that Java is able to manage threads, or the ability of Java to manage threads is enabling or is making the multi-threading convenient, because we have many details that are handled by Java. They are handled for us as programmers. So of essence, if you look at the Java thread, the Java thread model, we realize that the Java runtime system depends on threads for so many things. The runtime system of Java depends on threads for so many things. And also all the class libraries in Java are actually designed with multi-threading in mind. They are not just designed anyhowly. They are designed having multi-threading in mind. In fact, Java uses threads to enable the entire environment to be asynchronous. And when we have the entire environment asynchronous, then it means we are reducing inefficiency by preventing the waste of CPU cycles. Now, if you look at the single-threaded systems, they use an approach that we call event loop. We call it event loop with polling. And in this particular model, we have a single thread of controls that is run in an infinite loop, polling a single event queue to decide what to do next. So once this polling mechanism returns with, say, maybe a signal that, let's say, for example, a network file is ready to be read, then the event loop is going to dispatch the control to the event handler that is going to handle that network file. So until this event handler, to whom the control was given to, returns, there is nothing else that can happen in that program. Okay, for example, we got a signal that the network file is ready for use, and then control was passed to the event handler. Maybe we are trying to read in the file. There is nothing else that can happen in this kind of environment until the event handler is done, or it returns an event for a next event to take place. Otherwise, there's nothing else that can happen in the program. Now, this is disadvantageous in various ways. One, it is wasting CPU time. Number two, it can also result to in one part of a program dominating the system, and that is going to prevent any other events from being processed. So in general, when you're talking about a single-threaded environment, when a thread is suspended or suspends execution, that is, it blocks, maybe because the thread is waiting for some resource, then the entire program is going to stop. The entire program is going to stop. Now, the benefit of Java's multi-threading is that the main loop or the polling mechanism in Java is eliminated. So we can have one thread stopping its execution or pausing without stopping other parts of the program. For example, the idle time that is created when a thread is reading data from a network or waits for a user to input some user details, that can be utilized. The idle time can be utilized elsewhere. So we have multi-threading allowing animation loops to sleep for maybe a second between each frame without causing the whole system to pause. And when we have a thread that blocks in a Java program or is in a block state in a Java program, only that single thread that is blocked pauses. All the other threads continue to run. So we are maximizing on the CPU time. Okay. Now, many programmers will actually uh, or know that over the past number of years we have had multi-core systems that have become a commonplace in the IT, in the world of, in the field of IT. Of course, we also have single core systems that are also in widespread use. But it's important to understand that the Java multithreading feature is able to work in both types of systems, the single core systems and the multi-core systems as well. So in a single core system, we have the concurrently execution of threads that are sharing the CPU, with each thread receiving a slice of CPU time. Therefore, in a single core system, we have two or more threads that do not actually run at the same time, but idle CPU time is utilized. However, if you look at the multiple core systems, it is possible for two or more threads to actually execute simultaneously. And in many cases, you can further improve uh, the program efficiency and also increase the speed of some certain operations of the program uh, in such scenarios. Now, one last thing that I want to really look at and I want you to understand is something I call the thread states. Don't forget that we said a thread is basically a part of a program that can run simultaneously with other parts of that same program. It's important to remember that so that you don't get lost in our discussion. So, threads exist in several states, and I'm just going to give a general description. So the first one is a thread can be running. It can exist in a running state. Okay, a thread can be in running state. Number two, a thread um, can be ready to run. That is a state, ready to run. Number three, a thread also, of course, a thread can be ready to run as soon as it gets the CPU time. But again, when we can have a running thread that can be suspended. A running thread can be suspended. So suspended is another state. A running thread can be suspended. What do we mean by suspended? We mean it can be halted temporarily. It can halt its activity temporarily. Okay? But also, it's important for us to know that a suspended thread can also resume its activity. So we have resumed as a state. A suspended thread can also resume its activity. So we have resumed as a state. And when a suspended thread resumes its activity, what it normally does is it is going to pick up from where it left off in its activity. It is going to pick from there. Then it's also important to understand that when a thread is waiting for a resource, the thread can be blocked. So that is another state. The thread can be blocked when waiting for a resource. And last but not least, at any time, a thread can terminate. It can be terminated. So terminated is another state. It can be terminated. What we mean by terminated is it halts its execution immediately. And once you terminate a thread, the thread cannot be resumed. Only suspended threads can be resumed. Okay? So those are the various states of threads. That's important to also understand. Now, let's look at thread priorities. How are these threads given priority in terms of when they are being executed, when they are being run? How are they given priority? So we are talking about thread priorities. We're talking about thread priorities. Now, thread priority determines how a thread should be treated with respect to other threads. It determines how a thread should be treated with respect to other threads. So thread priorities are actually integers, and these integers specify the relative priority of one thread to another. So an integer is of course an absolute value. So it means that the integer or that priority is actually meaningless. In other words, I'm trying to mean that a higher priority thread does not necessarily mean that it can run faster than a lower priority thread. Okay? I hope that is clear. So instead, we use the thread priority to decide when are we going to switch from from a running thread to the next thread. When are we going to switch from a running thread to the next thread? We use the thread priority to determine that. Now the process now of switching from a running thread to the next thread is called context switch. This process is known as context switch. Okay, it's important that we call it context switch. When we are switching, we are switching from a running thread to the next thread. We call that context switch. So we have rules. There are rules that determine when context switching takes place. Okay, there are rules that determine when context switching takes place. They are simple rules, and the first rule is that a thread can voluntarily uh, relinquish control. It can voluntarily relinquish control. That is the first rule. A thread can voluntarily relinquish control. This is done by explicitly yielding or maybe sleeping or blocking on pending input or output. And in this scenario, all other threads are examined, and the thread that has the highest priority, that is ready to run, is given to the CPU. Now, the second rule is a thread can be preempted by a higher priority thread. A thread can be preempted by a higher priority thread. Now, let me just split this here so that you are able to see. This line is very long. I want you to be able to see my notes. Okay. Okay, so what do I mean by this? In a case of a lower priority thread, when you have a lower priority thread that does not yield the processor, that lower priority thread is simply preempted, no matter what that thread is doing. So if we have a lower priority thread running, and we have a higher priority thread that is ready to run, ready to take up the CPU, then the higher priority thread will preempt, okay, the lower priority thread, regardless of what that lower priority thread is doing at that particular time. Basically, as soon as a higher priority thread wants to run, it does. Okay, as soon as a higher priority thread wants to run, it does. And this is called preemptive multitasking. We call it preemptive multitasking. But the question comes, and the question insists, and the question is, what if? What about the cases where we have two threads that have the same priority, and these threads are competing for CPU cycles? Now, if you look at this situation, you realize that it is a situation that is a bit complicated. So for operating systems such as, for example, the Windows operating systems, threads that have equal priority are normally time sliced automatically. They are time sliced automatically using what is known as the round robin fashion. Okay, they are time sliced in a round robin fashion. But for other operating systems, the threads that have equal priority must actually voluntarily yield control to their peers. And if they don't yield control, then the other thread will not run. It is of essence for you to know that this can actually cause portability problems, resulting from the differences in the way the operating systems handle context switch of threads that have equal priority. I'm sorry, I'm not feeling very well, so I'm very sorry. I'm coughing in the midst of my my talking, so really sorry for that. Now, we said that multithreading brings introduces an asynchronous behavior. Multithreading introduces an asynchronous behavior to your programs as a programmer. It brings an asynchronous behavior to your programs as programmer. Now that means there must be a way for you to enforce synchronicity when you need it. When you need to have synchronicity, there must be a way for you to enforce it. Now, that makes me talk about synchronization. How do we achieve this? Remember I said here, there are a lot of things that you have to stuff in before we even go to writing code. Remember, it's important for you to understand the concepts even before you attempt writing any code. Now, for example, if you want to you want two threads to be able to communicate and share maybe a complicated data structure. For example, you want two threads to be able to share a linked list. Then you need some way to ensure that the two threads don't conflict with each other. That is, you must be able to prevent one thread from writing data while another thread is reading or is in the middle of reading the data that they are sharing. Now, for this purpose, the Java programming language implements an elegant twist on what we call the age-old model of inter-process synchronization, known as the monitor. Yeah, this is the old age model. It is known as the monitor. Now, let's understand this model. How does this model work? Okay. Now, the monitor is actually a mechanism that was defined by CAR Hall. I don't know if that's the correct pronunciation. And you can think of the monitor as a very small box that can only hold one thread. So once a thread enters that monitor, all other threads must wait until the thread that has entered the monitor exits the monitor. So in this way, we have a monitor that can be used to protect a shared asset from being manipulated by more than one thread at a time. Now, most multi-threaded systems expose monitors as objects that you can actually, or that your program must acquire explicitly and manipulate. But Java is giving us a cleaner solution. From the beginning, it's important for you to know that there is no class called monitor. But instead, each object is going to have its own implicit monitor that is automatically entered when one of the object's synchronized methods is called. So once a thread is inside a synchronized method, no other thread can call any other synchronized method on the same object. And that is going to enable you to write very clear and concise multi-threaded code, because synchronization is going to support the synchronization support is built in the language. Now, since we are dealing with threads, when you divide your program into separate threads, you need to define how these threads will communicate to each other. And that takes us to a concept I call messaging. Messaging. You have to define You have divided your program into threads, yes. Define how these threads will be able to communicate to each other. It is important for you to define how these threads will be able to communicate to each other. Okay? When a program with some, or when you're programming with some other languages, you must depend on the ability of the operating system to establish communication between threads. Okay? Now, of course, this is going to add overheads. Okay? But if we contrast the other programming languages with Java, Java is giving us a clean, we call it low-cost way for 2 or even more threads to be able to talk to each other via what we call calls. Calls are made to predefined methods that all objects have. So we have the Java's messaging system that allows a thread to enter a synchronized method on an object, and then it is going to wait there until some other thread explicitly notifies it to come out. Then it comes out. We are going to look at that practically. Right now, I just want you to swallow in the concepts. Now, for this part, let's take a break there. We stop there. I'm going to see you in the next part.